Hello class, welcome to the California State Fire Training Confined Space Rescue Awareness course. This course is divided into 9 lessons. Let's go over the course objectives for this course. 1. To introduce fire service personnel to the codes that impact operations within confined spaces. 2. Provide fire service personnel with the information to identify confined spaces and permit confined spaces. 3. Introduce fire service personnel to the hazards of confined spaces. 4. Introduce fire service personnel to the equipment and procedures required to deal with a confined space rescue safely and legally. 5. Introduce fire service personnel to the basic operational positions and their responsibilities as set forth by Cal OSHA. And finally, 6. To prepare fire service personnel for confined space entry rescue training. Now we'll move right into our first lesson. Introduction to Cal OSHA Code, Confined Space Identification, and Dangers. Let's review our Lesson 1 objectives. Recognize regulations governing operations in confined spaces. Identify the definitions of permit and non-permit confined spaces. Identify the differences between confined space and permit required confined spaces. Identify operations that make confined spaces dangerous. Why do we need to know this? Fire and police services responsibilities are overwhelming. Until recently, we may not have considered confined space rescue our responsibility, or if we did, we may have encountered it just as we would handle any other technical rescue. Research has shown that we cannot deal with confined space incidents like routine technical rescues, and regulations won't permit us to. Recent changes to state and federal regulations has caused many employers to reevaluate their confined space program. In an attempt to comply with these regulations, many employers are relying on outside rescue services such as fire and police departments. Requests for our services will undoubtedly increase. Thus, we must be well versed in confined space operations. Only through understanding what constitutes a confined space, the dangers they pose, and the regulations that apply to our operations in them, can we complete a safe and successful rescue. Let's take a look at the regulations affecting confined space operations. In February 1994, Cal OSHA enacted their final rule for confined space regulations. This can be found in Title 8 of the California Code of Regulations, General Industry Safety Orders, Sections 5156, 5157, and 5158. Outside California, federal OSHA has near an identical document. The American National Standards, ANSI, and the National Institute for Occupational Safety and Health, NIOSH, guidelines are also used in confined space rescues. Class question: why did OSHA update the confined space regulations? Well, let's take a look at some of the fatality statistics. Studies reveal that every year approximately 67 preventable deaths occur in confined spaces. As many as 60% of those deaths occur to would-be rescuers. Here's a graph chart going from 1980 to 1989, and this was given to us by NIOSH. Total deaths were 670 deaths due to confined spaces. Here is a pie chart that represents causes of fatalities in confined spaces. 65% of the deaths were caused by a hazardous atmosphere, 13% were caused by engulfments, 7% were caused by falling objects, 6% of the deaths were caused by heat stress, and of course 4% of the deaths were caused by other circumstances. The next couple slides, class, will be some news articles, and if you want to read them, you can stop the lecture and take a look at them. But here's a news article on 2 chemical plant workers found dead inside a boiler. This is another article. Talks about workers die after falling into a pit at a processing plant. Class question: what are other possible reasons or advantages from the new changes to the confined space regulations? Here's the answer. Recent changes in the confined space regulations also provide the mechanism for satisfying required injury and illness prevention elements with respect to confined space safety. The injury and illness prevention program should include the following: safety responsibility, compliance to the rules and regulations, employee-employer communication, workplace inspections, correction of the hazards that have been identified, injury and illness investigations, training, and record keeping. Let's take a look at the definitions of a confined space. Confined spaces, class, are subgrouped into 2 groups: confined spaces and permit required confined spaces. Let's take a look at a confined space and what the definition is. A confined space has limited or restricted means for entry, exit, and is an area large enough to enter to work and is not designed for continuous employee occupancy. Now let's take a look at a permit required confined space. It meets the definition of a confined space and contains one or more of the following. It would contain or has the potential to contain a hazardous atmosphere, contains a material that has the potential for engulfing an entrant, has an internal configuration such that an entrant could be trapped or asphyxiated by inwardly converging walls or by a floor which slopes downward and tapers to a smaller cross section. And it contains any other recognized serious safety or health hazard. Next, I want to show you some pictures of permit required confined spaces. Notice how this one has a converging wall and it goes all the way down to a point. You'll see whenever there's a confined space that requires a permit before people can enter to perform work, must have a sign posted outside, similar to the one you're looking at now. Here are some typical permit required confined spaces that you may find in your jurisdiction: storage tanks, pump wells, sewers, person holes, tunnels, underground vaults, boilers, silos, vessels, grain elevators, water towers, rail car tanks. Let me go over some dangers of confined spaces. They could be deficient in oxygen. They may contain byproducts of stored materials, such as in storage tanks could retain the residue, and the product could be absorbed into the tank walls. They could have leaks or spills, so they could leak of a substance which would give vapors off or cause reactions, and they could create a slip, trip, or fall hazard. They may have some chemical reactions, such as accidental mixing of chemicals, drying paint, or multiple use tanks. Oxidation can occur within a confined space, which would cause rusting of the metals and rotting or decomposing of organic materials. Confined spaces can pose a danger to mechanical operations such as welding, painting, cleaning, scraping or sandblasting, mixing or stirring operations, and recharging of batteries. They also contain inerting activities such as carbon dioxide, helium, and nitrogen. Here's another class question. What other hazards can be found in confined spaces? Let's take a look at the types of confined spaces. Confined space hazards are basically grouped into 6 groups. You have atmospheric hazards, physical hazards, engulfment hazards, corrosive hazards, biological hazards, and then other hazards. Class question. Are the following pictures examples of confined spaces? Is this an example of a confined space? How about the blimp? Is this an example of a confined space? What about a railroad boxcar? Does this meet the definition of a confined space? What about a seagoing container? Does this meet the definition of a confined space? What about this type of rail car? How about inside these tank cars? This could even be considered a confined space under OSHA's definition. How about this trench? Does this meet the definition of a confined space? How about the restroom inside Station 43? Does it meet the definition of a confined space? What about this portable restroom? Does it meet the definition of a confined space according to OSHA? How about this, if a maintenance worker had to get inside to perform maintenance? Or inside this water tower? How many of you have seen spaces like this in manufacturing areas or industrial complexes? How about this manhole? Here you see employees working inside the manhole. How many of you have seen underground utility workers working, such as in this picture? Or people building a tunnel? Look at the hazard that construction workers found inside this confined space. This is another example of why you have to look inside confined spaces. Look at all the snakes. All of those pictures that we just viewed are examples of confined spaces and permitted confined spaces. Let's summarize Lesson 1. Confined spaces are quite common throughout any jurisdiction. Whether these spaces are pipelines, underground vaults, tanks, grain silos, or any other configuration is not important. The critical fact is that we as rescuers can identify them as confined spaces and that we understand what makes them so dangerous. Only through training can we be confident that we will respond to these incidents with the information to be successful without placing ourselves in jeopardy. This concludes Lesson 1. If you have any questions, comments, or concerns, please email them to me, and I'll be more than happy to respond back to them or write the question down and bring it to class. We'll now begin Lesson 2, Atmospheric Hazards and Air Monitors. Let's review our objectives for Lesson 2. Identify what constitutes a hazardous atmosphere. Define the basic rules of air monitoring testing for confined spaces. Identify the target gases to be concerned with in confined space operations. Why do we need to know this? Confined spaces contain many hazards, one of which these is the potential for hazardous atmosphere. In fact, hazardous atmospheres account for nearly 65% of all fatalities that occur in confined spaces. It is imperative that we understand how to determine when a confined space contains a hazardous atmosphere. We must understand the process to follow to determine the hazardous atmosphere is present, as well as what some of the target gases are and their characteristics. The effects of hazardous atmospheres on workers and/or rescuers could be suffocation, poisoning, or an explosion/fire. Remember, in Lesson 1, we learned that 65% of fatalities occurring in confined spaces are a result of hazardous atmospheres. So let's talk about what is a hazardous atmosphere. It is an atmosphere which exposes employees to a risk of death, incapacitation, injury, or acute illness from one or more of the following. When the atmosphere contains an oxygen level below 19.5% or above 23.5%. The flammable gas or vapor in excess of 10% of the lower explosive limit, or airborne combustible dust is at a concentration that obscures a person's vision at 5 feet or less, or any immediately dangerous to life or health IDLH atmosphere. Let's talk a little bit about target gases and effects. Oxygen is considered a target gas. It must be between 19.5 and 23.5% by volume for atmosphere to be considered safe for human occupancy. When it's above 23.5%, the atmosphere becomes unstable and it's prone to flash fires or explosions. Below 16%, it causes physical effects that will become apparent on human beings. Let's take a look at the effects of various oxygen levels. When the percent of oxygen is between 19.5% and 16%, there's usually no visible effect. When it's between 16 to 12%, it causes an increased breathing rate, accelerated heartbeat. And when it's between 14 and 10%, it causes faulty judgment and poor muscular coordination in human beings. When it's between 10 and 6%, it causes nausea, vomiting, unconsciousness, followed by death. When it's below 6%, it causes difficulty breathing. It could cause convulsive movements and death in minutes. Another target gas is methane. It is colorless, odorless, and non-toxic. It is an asphyxiant, which means it displaces the oxygen in the atmosphere. It's lighter than air, and it has an explosive range of 5 to 15%. Another target gas is carbon monoxide. It is colorless, odorless, very toxic, and it's an asphyxiant, which means it displaces the oxygen in the atmosphere. And it has a vapor density that's equal to air. It has an explosive range of 12.5% to 74.2%. Let's take a look at the various exposure limits of carbon monoxide. If the rescuer or the worker is exposed to 100 parts per million for 3 hours or 600 parts per million for 1 hour, they will experience a headache and some discomfort. If they are exposed to 500 parts per million for 1 hour or 1,000 parts per minute for 30 minutes, they will experience a pounding of the heart, dull headache, dizziness, ringing in the ears, nausea. If they are exposed up to 1,500 parts per million for 1 hour, it becomes dangerous to life, and at 4,000 parts per million, it would cause a human being to collapse. Now let's talk about hydrogen sulfide, another gas that is commonly found in confined spaces. It is colorless. It smells like rotten eggs. It's toxic. It has a vapor density of 1.89, which means it's heavier than air. It has an explosive range of 4% to 44%. It's common in sewage facilities, and it diminishes your sensitivity to smell. The rapidly negative impact to the entrance olfactory, which is your sense of smell system, makes many people believe this gas is no longer present, when in fact, it is still at deadly levels. Let's take a look at the various exposure levels of hydrogen sulfide. If the worker or the rescuer is exposed to 15 to 25 parts per million, it'll cause them eye irritation. If they are exposed to 50 to 150 parts per million for several hours, they'll have some type of slight eye or respiratory irritation. If they are exposed to 170 to 300 parts per million for 1 hour, they'll have marked irritation. 400 to 600 parts per million for a half hour to 1 hour will cause unconsciousness and lead to death. And at 1,000 parts per minute, it'll become fatal in minutes. Now let's talk about sulfur dioxide, which is another gas that's commonly found in confined spaces. It has a pungent odor. It's an irritating gas. At 1 to 10 parts per million exposure will cause respiratory and a pulse rate to increase, and you'll also notice a decrease in the depth of respirations. It has a vapor density of 2.26, which means it's heavier than air, and it's non-flammable. Carbon dioxide is another gas that's found in confined spaces. Remember, carbon dioxide is colorless, odorless. It's a non-combustible gas. It's very toxic. The exposure symptoms would consist of headache, dizziness, and restlessness, and it also has a vapor density of 1.53, which is heavier than air. Here's a word of caution. Relying heavily on a suspected gas to be lighter or heavier than air to determine its location in a space can be a fatal mistake. Gas concentrations high enough to be toxic can float along with the rest of the air molecules. They neither sink or rise. Here's a class question. How can we be sure that hazardous concentrations of these gases are not in the confined spaces that we have to enter to perform a rescue? We use atmospheric monitors. There are several types of air monitors and alarms that are used during confined space rescue operations. We have single gas monitors, and they will only monitor one preset gas. Then we have multiple gas monitors, and they will monitor multiple gases that have been preset by the manufacturer. Monitors that sense 4 gases at once are commonly used in confined space operations, and we refer to them as a 4-in-1 monitor. Here are some examples of some 4-in-1 monitors. Here's another example of some monitors. Now you'll notice in this type of monitor it has a long tubing. This allows the person that's monitoring the gases to slip that long tubing down into the confined space without having a human being enter the space, so they can check for toxic levels of gases before they enter the space. Now let's talk a little bit about some monitoring operations. Monitoring should be done in the following order each and every time. First, we'll check the confined space for the oxygen content. Second, we'll check it for flammable gases and vapors. And third, we'll check it for potential toxic contaminants. Testing should be done prior to lifting the manhole covers or person hole covers to get the most accurate reading and to eliminate potential explosions. Testing should be done at all levels of the confined space. Remember, stratification of gases may occur due to vapor density of gases because they vary. Testing must continue periodically throughout the rescue. Results of monitoring must be logged on the entry permit as well as a data log of the monitor equipment. In this picture class, you can see a firefighter getting ready to monitor the gas for different toxic levels. All right, let's summarize this lesson. Atmospheric conditions are the #1 killer in confined space incidents. Only by confirming what the atmospheric context of the space is can we enter the space with the appropriate protection in place. To do this, we use atmospheric monitors by sensing first for oxygen, then flammable gases and vapors, and then potential toxic air contaminants. It is imperative that we have a knowledge of target gases found in confined spaces and the effects they may have on our rescuers. In addition, we must continue to monitor throughout our operations so that we can eliminate the potential for death or injury due to changing atmospheric conditions, as can occur in sewer operations. This now concludes Lesson 2. If you have any questions, comments, or concerns, please email them to me, write them down, bring them to class, or give me a call, and I'll be more than happy to answer your questions. Now we move into Lesson 3, Physical and Engulfment Hazards. Let's take a look at our learning objectives for this lesson. Recognize what constitutes a physical or engulfment hazard. Identify target industries that routinely have physical or engulfment hazards. Why is this important to us as firefighters? NIOSH reports for the period 1980 through 1989 that 227 lives were lost in confined spaces as a result of engulfment. 124 deaths were caused by grain. The remainder were fertilizer, cement, gravel, sawdust, etc. Regardless of the material, most of these victims miscalculated the stability of the material they were walking on. In addition, many others lost their lives due to equipment in the spaces. This equipment either caused them to fall or they became caught or disfigured in or by the equipment. Only identifying the hazards early and using appropriate safety equipment can we reduce our chances of becoming one of these statistics. Now let's talk about some of the physical hazards. We have grinding equipment, agitators, mulching equipment, drive shafts, gears or other moving equipment, steam, electrocution, falling objects. All these are possible physical hazards that we can encounter in a confined space. Here's a class question. What materials do you think provide a potential for engulfing an entrant? Let's go over the materials involved in engulfment incidents. We have sand, gravel, grains, cement, clay, sawdust, and liquids. All of these that you see on your screen now, class, are considered engulfment hazards. Now let's talk about some of the causes of engulfment incidents. Walking on unstable material that has void spaces below is called bridging. This is a cause of an engulfment incident. Improper use of safety and retrieval lines, overhead flow of particulate matter or liquids activated inadvertently. Now let's take a look at the physical and engulfment hazards that confined space rescuers encounter. Industry with mechanical assembly equipment, grain or particulate matter productions or processing, and industries that have spaces with bottom dump applications. All these are potential physical and engulfment hazards. Next, I want to talk about some of our target industries. Now, target industries are industries that have been identified in your jurisdiction that a physical or engulfment hazard exists or could exist. Physical and engulfment hazards are located in industries with mechanized assembly equipment, spaces with electrical, hydraulic, or pneumatic equipment supplied to it or within it, grain or particulate matter production or processing. Industries that have spaces with top load applications and industries that have spaces with bottom dump applications. All of these type of industries are considered target industries and have been identified in the authority having jurisdictions through their pre-planning process. Now let's summarize this lesson. Physical and engulfment hazards are the number 2 killers of personnel in confined spaces. If no other reason than this, these hazards demand our utmost attention. Unfortunately, though confined spaces make it difficult to identify hazards and secure them. By their very nature, confined spaces concentrate hazards, making it difficult to separate the worker from the hazard. Facilities relying on outside rescue services, fire and police departments, are required by Cal OSHA to provide access and opportunity for rescue pre-planning. And it is during this rescue pre-planning class is where we identify these target locations. It is to our advantage to capitalize on the opportunities so that we can fully understand our potential rescue problems. By pre-planning what industries are in our jurisdiction and researching the hazards, we can reduce our risk and work safely in a potentially dangerous environment. This concludes the Lesson 3. If you have any questions, comments, or concerns, please write them down, bring them to class, or give me a call, and I'll be more than happy to answer your questions. We move right in to Lesson 4, which talks about lockout tagout procedures and the required entry permits. Let's take a look at our learning objectives in Lesson 4. By the time we get done with this lesson, we should be able to recognize the need for lockout tagout procedures, define techniques of lockout tagout, identify the components of an entry permit, and identify operations that are permit exempted. Why do we need to know this as firefighters? Inside any given confined space, there can be numerous life-threatening hazards that are present. Many of these hazards are a result of potential energy sources that can power equipment or move product in a way that can catch the entrant off guard and injure or kill them. To eliminate this potential, we have developed procedures and equipment to lock out and potential energy source and to tag out the equipment so that all other parties will be aware of the shutdown. A confined space rescue incident requires the consideration of many things and the documentation of a lot of information. To reduce the chances of any considerations being overlooked or information not being documented, a formal entry permit has been established. This document is used much like a tactical worksheet. Cal OSHA provides an example of one in Title 8, Appendix D-2, Section 5157. Each jurisdiction can develop an entry permit that best suits their need, but it must include all of the components that are set forth by Cal OSHA. Let's take a look at some of the lockout-tagout procedures. Procedures performed to isolate any potential energy source to the space is the purpose for a lockout-tagout procedure. We can shut down electricity, and we can shut down hydraulics, and we can shut down steam. We can lock out, tag out drive mechanisms, and we can lock out, tag out pneumatic devices, and we can lock out, tag out the gravity flow of a product. The lockout, tag out procedures must be performed by an authorized employee. Here's a class question. How do other workers and rescuers know that the energy source should remain locked out? Here's the answer for your written test. Printed tags and locks are used to warn other employees of isolated energy source. Here on this slide, class, is an example of a lockout tagout kit that would be carried on a rescue vehicle. As you can see here, we use regular padlocks to lock out this device. In this slide, we use a chain and a lock and a tag to let people know that this device has been shut down, and now it's locked out and it's tagged out. Here's an example of a lockout tagout that was placed on this device. Here's another example of a lockout tagout. And you can see here we use padlocks and a visible tag. Here's another example of where we shut off the gas using a lockout tagout. Here's an example of a fuse panel or electrical panel where we used a lockout tagout system to shut off the power. This is an example of what we call a double block and blend. This picture here gives you an idea on how we would lock out, tag out a hydraulic line. So what we do is we shut off the two valves, okay, shutting off the flow of the hydraulic fluid, and then right below it we would open up the bleed valve and drain whatever the fluid is out of the hydraulic line. This is called the double block and bleed method of shutting down a line that's carrying some type of hydraulic fluid. And here are some more examples. Some of these examples you've seen in the past few slides that would require a lockout tagout. Shutting off electrical switches, hydraulic lines, we just saw the last slide, the block and blend method, the steam line blind flanged, drive mechanisms disconnected, drive belts removed, and overhead dumps locked out. Let's talk about an entry permit. An entry permit is a formal written document that lists those requirements that must be completed and documented to make a safe and legal entry. These entry permits must be approved by the entry supervisor, and upon completion of entry, the permit must be signed and canceled by the entry supervisor. The permit must be filed and retained at least for 1 year. Let's take a look at the components of a confined space entry permit. It would contain the location of the confined space, the purpose of the entry, the date of the entry and authorized duration, the list of the attendants, the entry supervisor's signature, the list of all necessary tools and equipment. It would list all special hazards, the results of initial and periodic atmospheric tests, measures to isolate the space and control the hazards prior to entry. It would list of rescue and emergency services that were present on scene, and it would also list the communications procedures. All these that you see in front of you here are components of a confined space entry permit. Here's an example class that I took off of CAL FIRE's website of a confined space entry permit. This would be page 1 of the permit. And again, if you want to look at it in more detail, you can look at it in the lecture notes. This is page 2 of the permit. There are some exemptions to the confined space permitting process. Exemptions are granted due to regulation by other sections of the California Code of Regulation or the Code of Federal Regulations. The following are exemptions. You don't need confined space permits for selected construction operations that are defined by Section 1502, selected agricultural operations that are defined by Section 347, marine terminal operations that are defined in Sections 3460, and shipyard operations that are regulated by Section 8437. Other exemptions include telecommunications, people holes, and vaults that are regulated by 8616. Now, all these sections are from the California Code of Regulations. Grain handling facilities as defined by Section 5178, and electric utility operations within underground vaults. Exemptions are based on employer proof of atmospheric hazard only. They must not contain any other hazards except an atmospheric condition only, and the hazard can be eliminated by ventilation alone. When exemptions are granted, components of the normal entry program may or may not be present. An entry permit may not be provided, and the entrant lowering and retrieving the equipment may not be present. Exemptions are only valid when the entry is for the prescribed purpose. To evaluate an injured worker out of an exempted space would nullify the exemption in Sections 5156 and 5157, and 5158 would prevail. Lockout, let's summarize this lesson, class. Lockout tagout procedures are those procedures that are performed to isolate any potential energy source and to mark its deactivation so that other workers cannot turn the source back on. These procedures are essential to a confined space incident so that the entrants will not be injured or killed by material or equipment in the space. Entry permits are a formal written document that lists those requirements that must be completed and documented to make a safe and legal entry. This document is used much like a tactical worksheet and must be completed at all permit required space entries unless the operation meets the criteria of one of the many OSHA exemptions that I just talked about. It is imperative that we complete an entry permit when performing rescues and that we request the entry permit that was completed at the site prior to our arrival to use as a reference for understanding the current situation. This concludes Lesson 4. If you have any questions, comments, or concerns, please write them down, bring them to class, or you can send me an email with your question and I'll answer it, or you can just simply pick up the phone and give me a call. We're now into Lesson 5, ventilation equipment and techniques used during confined space operations. Let's take a look at our learning objectives here. 1. By the time you finish this lesson, you should be able to identify the 3 principal ventilation plans and recognize considerations that will impact the ventilation operation. Why do we need to know this as firefighters and rescuers? Ventilation operations should be performed whether or not respiratory protection is in use when entering a confined space. Ventilation procedures will limit the chances of toxic or explosive atmospheres from developing. Certain specialized equipment will make the operation more effective and easier. Numerous conditions and circumstances will impact the ventilation operation. These conditions must be considered when developing your ventilation plan. Let's take a look at some of the ventilation equipment that is used. We can use industrial fans as ventilators, smoke ejector fans, ductwork. Here's an example of a fan used to ventilate confined spaces. Ventilation plans are carried out in one of 3 ways. We can either use forced supply ventilation, forced exhaust ventilation, or forced supply and exhaust ventilation. Here's an example of forced ventilation. Here's an example of another type of ventilation using the exhaust fan. Here's a type of ventilation called short-circuiting ventilation. It's when we put the ventilation fan at the top or the opening and we force clean air down into the space, which forces the contaminated air and the exhaust air out of the other open space. This type of ventilation is called recirculating, although it's not recommended, but you can see where we have the exhaust fan on top of the confined space with a tube that goes down almost to the bottom, and it uses the recirculating air. The bad part about this type of ventilation is that you can reintroduce the contaminated air. I now want to talk about some considerations for our ventilation plan. We have to take into account the configuration of the space, the number of openings in the space, the locations of the openings, whether they're vertical, horizontal, or at the bottom. We have to determine the vapor density of the suspected vapors, the wind direction, and the equipment available. Here's an example of a group of people ventilating the inside of a tank. You can see the exhaust fan and the tubing going up to the top. Let's take a look at some of the ventilation plan hazards that we have to consider. Directing exhausted explosive vapors towards any ignition sources, directing vehicle exhaust or other hazardous vapors into our supply fans, changing a non-explosive atmosphere into an explosive atmosphere, Diluting an atmosphere that is above its upper explosive limit down below its explosive range would require passing through that explosive range. Let's summarize this lesson. Ventilation operations are a critical component of the overall confined space rescue procedure. Cal OSHA Title 8 addresses ventilation in Section 5157C of the General Requirements. This section basically states that forced air ventilation will be initiated prior to entry and that it shall continue until all entrants have left the space. Your ventilation operation will generally fall into three categories: forced supply, forced exhaust, and forced supply and exhaust. Many factors will impact which operation you may choose or the particular technique. Specialized equipment has been developed to make the task of ventilation easier and more effective, although basic equipment will suffice when specialized equipment is not available. Regardless of the circumstances or equipment available, ventilation operations must be completed to reduce the chances of a buildup of toxic or explosive gases. This concludes Lesson 5. If you have any questions, comments, or concerns, please write them down, bring them to class, or send them to me in email, or give me a call. I'll be more than happy to answer them for you. Let's now move on into Lesson 6, Respiratory Equipment and Techniques. Let's take a look at our learning objectives. By the end of Lesson 6, you should be able to recognize the need for respiratory protection in confined space operations, identify the different types of respiratory protection suitable for confined space operations. Why is this important to us? Once the atmosphere has been tested, proper respiratory protection must be selected. There are many different types of respiratory protection systems available. Your choice will be impacted by your needs and the features of the given equipment. When performing confined space rescue operations, you need to have respiratory equipment ready for immediate use regardless of the present condition, as the atmospheric conditions can be unpredictable. Let's take a look at the respiratory protection requirements. Respiratory protection must be provided in personnel trained if the following conditions exist. Testing demonstrates the existence of dangerous or deficient conditions, and additional ventilation cannot reduce concentrations to safe levels. The atmosphere tests as safe, but unsafe conditions can reasonably be expected to develop. It is not feasible to provide for ready exit from spaces equipped with automatic fire suppression systems, and it is not practical or safe to deactivate such systems. An emergency exists, and it is not feasible to wait for pre-entry procedures to take effect. Again, these are all respiratory protection requirements. Let's talk a little bit about the respiratory protection classification. The first one is self-contained breathing apparatus. It is considered the highest level of respiratory protection, and the supply is carried with the entrant. It contains no air hoses to outside to restrict the entrant's movement. The cylinder size can cause difficulty, however, in tight confined spaces. Here's an example of a self-contained breathing unit used in this confined space. Next, let's talk about an escape cylinder. It's best suited for confined space rescue. The air is supplied to entrant's mask from outside the space. It's capable of endless air supply. It must include an escape cylinder, and the air line is not to exceed 300 feet from the source. Here's an example. This is the escape bottle, and here's the outside source. You can see this is another view of the outside source providing purified air to our rescuers. Next, I want to talk about the air purifying respirator. We have to make sure that the space we're going to enter is not oxygen deficient. The cartridge must be specific to vapor, mist, fumes, dust, or etc. An air purifying respirator is not recommended unless conditions are known and can be maintained. Here's a newspaper article that you can take time to read in your lecture notes. 2 construction workers run out of air and die. This was in Chino, California. Here's another news article. Nearly airless vault claims the lives of 2 rescuers. Let's summarize this lesson. Appropriate respiratory protection at a confined space rescue incident will eliminate the possibility of entrants falling prey to the #1 killer in confined spaces, atmospheric conditions. According to Cal OSHA regulations, respiratory protection is not required in all situations, including some rescues. Regardless of the regulations, it is widely accepted that rescuers should enter with full respiratory protection due to the uncertainty of conditions coupled with the potential for a stratification of gases. Respiratory protection systems include the normal self-contained breathing apparatus, a combination dual-purpose SCBA, supplied air respirators with an escape cylinder, and air purifying respirators. All of these types have certain applications, although air purifying respirators are not recommended. Training and familiarity of the equipment is imperative for personnel using this equipment in confined space operations. This concludes Lesson 6. If you have any questions, comments, or concerns, please write them down, bring them to class, shoot them in an email to me, or give me a call. I'll be more than happy to answer your questions. Thank you. We are now into Lesson 7, Communications Equipment and Techniques. Let's take a look at our learning objectives for Lesson 7. By the end of this lesson, you should be able to define the requirements for communication systems, identify the different types of acceptable communication systems. Why is this important to us? It is imperative that confined space entrants be able to communicate with the attendants. Only through a communication system can both parties be aware of problems that may require evacuation of the space. Cal OSHA understands the importance of communication during confined space operations and enforces regulations requiring a communications plan to be in place. There are a number of different communication plans/techniques that comply with the regulations. The environment and cost are 2 main considerations when deciding upon equipment. Now let's talk about communication equipment. The attendant and entrant must be able to communicate. The equipment must be battery-operated portable radios, capable of push-to-talk operations, or it can be voice-activated operations. People can use an ear mic as an option, and you can have 2-way multiple users. Most importantly, the electronic equipment used must be intrinsically safe. Let's talk about hardwire systems. You can have push-to-talk operations. They can be voice-activated operations. You can also use an ear mic option. You can have a conference operation with multiple users using this type of communication system. The hardwire can restrict movement The electronic equipment also must be intrinsically safe. Hand signals is another way to communicate. We use basic, simple hand signals. They must be committed to memory. You must have a visual contact with the person you're communicating with. Another way we communicate during confined space operations is with rope signals. We keep them very simple, and we use the mnemonic OATH, O-A-T-H. The entry team shall maintain constant radio communications with the officer in command. Should radio communications fail or not be used, communication shall be maintained with the lifeline. The following rope signals will be used to communicate basic messages. One pull on the rope stands for O, which means OK. Two pulls on the rope stands for A, which means allow slack. Three pulls on the rope stands for T, which means take up slack. And four pulls on the rope stands for H, which means help. Using this method, you must commit the mnemonic oath to memory. It has limited application, and it is recommended that each entrant wear a personal distress device, known as a PDD, as well as the communication system. Per Cal OSHA regulations permit required confined spaces. This communication is normal operations. Communication equipment and procedures to maintain contact between entrants and attendants must be provided. Permit required confined spaces with any of the following conditions required communication. The atmosphere test as safe, but unsafe conditions can reasonably be expected to develop. Testing demonstrates the existence of dangerous or deficient conditions, and additional ventilation cannot reduce concentrations to a safe level. Or it is not feasible to provide for ready exit from spaces equipped with automatic fire suppression systems, and it is not practical or safe to deactivate such systems. Or an emergency exists and it is not feasible to wait for pre-entry procedures to take effect. Continuous powered communications equipment shall be maintained between the worker within the confined space and standby personnel in the above listed situations. Let's summarize this lesson. A communication plan is required on confined space entries. There are numerous types of equipment available, including portable radios, hardwire systems, hand signals, rope signals, etc. The choice of what type of equipment plan is left up to the employer, except in more critical situations where regulations require continuous powered equipment. Regardless of what type of equipment is used, the overriding factor is to provide a reliable communications link between the entrant and the attendant. This concludes Lesson 7. If you have any questions, comments, or concerns, please feel free to email them to me and I will respond back. Write them down, bring them to class, or give me a phone call. Be more than happy to talk to you about it. We will now begin Lesson 8, Entrant Retrieval Equipment that we use in confined space operations. Let's take a look at our learning objectives for Lesson 8. At the end of this lesson, you should be able to recognize regulations governing entrant retrieval equipment and operations. You should also be able to identify the equipment needed to successfully complete entry and retrieval operations. This is why it's important. NIOSH and OSHA studies reveal that as many as 60% of the deaths that occur in confined spaces happen to would-be rescuers. Proper use of lowering and retrieval equipment allows for the possibility of non-entry rescue procedures. Thus, no one in addition to the original entrant is placed in jeopardy. The equipment used to provide this protection can be complex and expensive, or fashioned from life safety rope and basic rope system hardware. Regardless of the system you choose to use, you will need to understand the requirements of the code and practice with this equipment in order to maintain your skills. Let's take a look at the OSHA requirements for retrieval equipment. OSHA requires retrieval line and fall restraint when vertical entry of 5 feet or more below grade is made. The retrieval line must be attached to a mechanical device outside the space. Entrants are to stay on line unless this would increase the entrant's risk of injury. Staying on line allows for non-entry rescue. Let's go over some anchoring devices. I want to talk about a high point anchor. We use tripods, ladder gin, ladder A-frames, and a davit arm. Here's a tripod. Here's a ladder gin. Here's a ladder A-frame. Here's another example of a ladder A-frame using a ratchet cam with a haul line. And here's an example of a davit that's being used as a retrieval line. Let's talk a little bit about mechanical advantage systems. We can use a hand crank mechanical winches with a cable, or we can use rope and pulley systems. When lifting entrants, power equipment is never used because resistance cannot be felt. Here's an example of a hand crank mechanism. Another shot of a hand crank used in confined spaces. You can see in conjunction with the tripod. The skills used in confined space rescue are used in all other forms of technical rescue. You can see low angle rescue, and you can also see high angle rescue. Let's take a look at the entrant/victim harnesses that are used in confined space. We have the full body harness, which is the class 3, and you can see examples of it in the lower right of your screen. We use also ones with wristlets or tight openings and or for unresponsive victims. Here's an example of a type 3 harness being used in a confined space rescue. And you can see we can use those wristlets on the rescuer's type 3 vest to put the hands of the victims in to keep them from dangling. Here you can see they're finally getting them out of the confined space. Notice the ventilation tube in the back. Here he is being lowered with a tripod. Notice the self-contained breathing apparatus. Notice the tripod that's being used. Now I want to talk about the body immobilization devices that we used in confined spaces. We used a Miller board, which immobilizes the patient's upper body. We can use a Stokes litter or a sked sled. Here's an example of a sked sled, and you can see it just wraps right around the victim inside the confined space, and it makes it very easy to maneuver the victim within the confined space. It actually works pretty good for unresponsive patients. Here you can see the fire department getting ready to bring him up vertically through the opening. Notice the rope there as well. And here he is being extracted out of the top of the manhole cover. Let's summarize this lesson. The use of approved retrieval equipment allows for the possibility of non-entry rescues. Non-entry rescues eliminate the risk that rescuers are subjected to when forced to make entry rescues. The equipment used for entrant retrieval can be quite complex or can be simply constructed from common rope systems. Regardless of what type of system you use, it must fasten to the entrant on a full body harness at a high point in the center of the back or above their head. In addition, the system must provide fall restraint in case the entrant was to slip or fall, and provide some type of mechanical device to assist in raising or retrieving the entrant. This concludes Lesson 8. If you have any questions, comments, or concerns, please feel free to call me, write them down, bring them to class, or you can email them to me and I'd be more than happy to answer the questions. Thank you. Now we move into our final lesson of confined space awareness, Lesson 9. Permit required confined space operational positions and responsibilities. Let's take a look at our learning objectives for Lesson 9. By the end of this lesson, you should be able to identify the 3 operational positions identified by OSHA, recognize the duties of each of the 3 positions identified. It's important for us to understand this because OSHA identifies 3 main operational positions to perform the task that must be done to safely operate in confined spaces. Each of these positions have duties which are outlined in Title 8 of the California Code of Regulations, GSIO, Section 5157H, I, and J. These positions fit easily into the normal fire service incident command system chart and must be identified and filled in confined space rescue operations as well as for industrial purposes. Let's go over the duties of each one of these attendants. They must know the hazards and the signs and symptoms associated with known hazards. They have to understand the behavioral effects, and they have to maintain count and identities of each entrant. They must remain outside the space until they are relieved, and they must communicate with entrants as needed. They must perform monitor activities inside and outside the space, and initiate on-site rescue procedures, and secure a safe perimeter. These are all duties of attendants. Perform non-entry rescue as well, and perform no duties that might interfere with the primary duty to protect the entrant. The next position in a confined space operation is the entrant. So we just went over the attendant. Now we're going to talk about the entrant. The entrant must know the hazards during entry, properly use all of the safety equipment and rescue equipment. They must communicate with the attendant as required, and they must alert the attendant if situations warrant, and they must exit the space immediately if the situation warrants. The third and final position in confined space operations is the supervisor. The supervisor verifies that the entry permit is completed and approves the permit. They must know the hazards during the entry, and they must terminate entry and cancel the permit when required. They verify that additional equipment and services are present. They confirm that entry operations remain consistent with the entry permit. And due to the common problem of a shortage of staff at a rescue scene, it is recommended that attendants, entrants, and the entry supervisors be trained identically, allowing flexibility of personnel assignment. Let's summarize Lesson 9. OSHA requires that the employer provide training so that all employees working in confined spaces acquire the understanding, knowledge, and skills necessary for safe performance of the duties they are assigned. In addition, OSHA identifies 3 positions to operate within confined spaces: attendants, entrants, and entry supervisors. Each one of these positions has specific responsibilities. When these positions are filled and performed as required, the chances of accidents and oversights are generally reduced. This concludes the California State Fire Training Confined Space Awareness lecture. Please take a few moments and review your lecture notes and watch the following videos. Thank you.